Hey guys, welcome back. So what we're looking at here is 6.6 symmetries of regular polygons. So what we're doing here, what I'm showing you is some of the different kinds of symmetry that we have. So we have both line and rotational symmetry. So looking at this, our equilateral triangle has 3 lines of symmetry. It can rotate 3 times, 120, 240, and 360. It can always rotate 360. That'd be back to its original position. And so rotational symmetry means we can take this whole figure and take this point up to this point, which would be 120 degrees, and it'll perfectly line up back on itself. A pentagon has 5 lines of symmetry. Pentagon also has 5 sides, and it's got 1, 2, 3, 4, 5 angles of rotational symmetry, including the 360, which I didn't write on any of these. A square has 4 lines of symmetry and 4 angles of rotational symmetry. A hexagon has 6 lines of symmetry and 6 angles of rotational symmetry. Hopefully you're noticing a pattern here. So an octagon would have 8 lines of symmetry. I'm not going to draw them all. And a nonagon would have 9 lines. It would also have 9 angles. So lines of symmetry, n lines of symmetry in a regular, which means all the sides are the same, n-gon. So however many sides there are, that's how many lines of symmetry it has. What do you notice about the rotational symmetry? Well, it's 360 divided by n. We take however many sides there are and we divide it by we take the 360 because that's a full rotation and divide it by how many sides there are. That gets us the angle of rotation, so we can keep finding those values. All right, so for number 1 here, what fraction of a turn does the wagon wheel below need to turn in order to appear the very same as it does right now? How many degrees of rotation would that be? So first we count. We've got 1, 2, 3, 4, 5, 6, 7, 8. This has 8 spokes. So this is like an octagon. So 360 divided by 45, divided by 8 is going to give us 45 degrees. So it's 45 degree rotational symmetry, and 1 turn on this would represent 1/8 of a rotation. So same idea for 2 and 3. So we're looking a lot at these rotational symmetries. So rotational is your key word for this lesson. All right, the next part. So you will be drawing. If you don't have them drawn, you will lose points. So make sure you draw all the lines of symmetry here and list them out. Remember, the number of sides is the number of lines of symmetry. That should be helpful. All right, now the diagonals. The diagonals are rather complicated. So in a triangle, there aren't any diagonals. We can't go from one vertex to a non-adjacent vertex. But in a square, we can. So from this vertex, we have the option to go there. We can't go to either of the other two. And then we can do that. So a square has 2. Now, a pentagon, we can, starting at any vertex, doesn't matter which one you start at. I'm going to go here. We can go over there and over there. So basically, we're drawing lines to all the other vertices. But notice, from this vertex to this vertex, there's already a line. It's one of the sides, so it's the non-side line. So we've got 2. So we can do the same thing here. There's 3 and 4. There's 5. So it has 5 diagonals. Now, a hexagon, same idea. Pick a vertex. We do, 1, 2, 3. We do 1, 2, 3. We do 4. That one already had 1. 3, 3, 6, 7, 8. I know it's really, really messy. But you want to make sure that you get all of them. That one has 3. So basically, look. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. So as long as every vertex has 3, you're good, because that's how many there are that don't touch this vertex. There's 3 other vertices that don't touch this one. So if we look at this, so 6 had 9. So this one we've got the 2 vertices right here, but then we have 1, 2, 3, 4 vertices that don't touch. So out of each one of these, we should have 4 lines coming, which is going to result in 14. And then in 8, there's going to be 1, 2, 3, 4, 5 coming out. We're going to end up with 20. I'm not going to try to draw those because it's going to get really, really messy for me, but you guys need to. So draw out those lines of symmetry. And yes, it's going to look like a lot of lines and be very, very messy, but you can do it. You'll have it a lot easier than I do on the computer. So this is the rule for how we find the number of diagonals, n minus 3, because obviously there's 3 vertices involved when we look at any given point. So we do n minus 3. And then we multiply that by the number of sides there are, and then we divide it by 2, and that gives us our total. All right. For number 7, what are the angles of rotation for a 20gon? How many lines of symmetry, lines of reflection, will it have? Well, we know it's going to have 20 lines of symmetry. And if we take 360 and divide it by 20, we get 18. So multiples of 18 degrees would be our answer. So rather than listing out 18, 36, 54, 72, 90, 108, 126, 144, so on and so forth, you can just write multiples of 18 is perfectly fine. All right, for number 9, how many sides does a regular polygon have that has an angle of rotation equal to 18 degrees? Well, ironically, we just looked at this, but in order to solve it, we'd have 360 over n equals 18. Multiply n to both sides. So we have 360 equals 18n. Divide by 18, and we get 20. So 20 sides would be how many there would need to be in order to have a degree of 18. All right. Our last section here, we are looking at reflecting and rotating points in the coordinate plane. So we've got both shapes as well as singular points that we want to take and reflect. So remember, when we have that line of reflection, it's perpendicular. So we find the slope of the line, then we do the perpendicular slope to move the point to the other side. So for this one right here, our slope here is up 1, 2, 3 over 1. So it's a 3 over 1 slope. So opposite reciprocal would be negative 1/3. So we're already going down. So we go up 1 and to the left 3. 1, 2, 3. We got to the line. So we go up 1 and to the left 3 more. And so right there is going to be our A prime. It's going to have the coordinate of -5, -2. So that's what you guys are looking at here. Remember, find the slope between them so you can draw the line. For these, notice it's vertical. It's going to be a nice vertical line for you. So 1, 2, 3, 4, go 2 over. This line right here will be your line of reflection. Obviously, mine's very wobbly, but it'll be x equals -1. All right, if you guys have any questions, feel free to ask. Have a great day. Bye, guys.